Hello and welcome back to Simply Dev. Today I'm going to be showing you how to make this, a nice and simple tool that can make placing objects that much easier. Say we have a plane in our scene and we want to distribute some objects along it, whether that be trees, lampposts, benches, whatever. All we have to do is drag our object into here, and you can see we can choose how many objects we want to place along the lines. It will place them at even distances between them, depending on what you set this steps variable to. So if you want a couple or if you want a lot. You can make them face towards the destination, but it is a bit buggy depending on the object and how the pivot's set up. Now you can see even if we move the goal, it will live update them in the editor, so you don't have to worry about it. You can adjust it however you want. And then when you're ready, all you have to do is you can just unparent this path and get rid of the main objects. You can see we have an empty that contains all of our objects. We can cycle through them. We can do whatever we please. We can change stuff, etc, etc. Let's get into it. So to start, we're going to need two C# scripts. We can do this by coming to Assets, Create C# script. We're just going to call this Generator Editor, as this is going to contain the code that lets us add the buttons to the editor. Okay, so what we're going to do, we're going to first get rid of our default functions that Unity provides us, as we don't need them. At the top, we're going to type using Unity Editor. And just above our class definition, we need to give it a flag. This is going to be custom editor type of generator. It will be fine if this is underlined at the moment. It's just because we haven't created the script. Instead of inheriting from mono behavior, we're just going to change it from editor. This just basically allows us to add our own buttons and such. We need to do this inside our public override method, return type void, and on inspector GUI. We're going to draw the default inspector because we still want all our default stuff, our transforms, the ability to see any other objects, add scripts, that sort of stuff. Now we're going to create a type called generator, call it gen, set that equal to generator target. These will be showing up as an error until we can actually create the script, but we don't have to worry about it for the moment. Here's where we're going to do our buttons. We need 3. So to do this, we're going to do if GUI layout button generate path. So this is going to be the text that's inside the button. We need another for delete path. And one for purge all paths. We're going to add one more button. This wasn't in the demonstration, but we're going to make this now. And we're just going to call it finalize. Now, the object for this button will just be to separate the empty object that all the items get created in and delete the origin and goal points. So in generate path, we're just going to run the gen.generate function. Delete path, we're going to run gen.delete. Purge, gen.purge. And finalize, gen.finalize. So that's it for this script. In Unity, we can create another script and we're going to call this generator. You can see as soon as we do that, most of the issues go away, just these functions that we haven't created. So let's start by doing that. So void, generate, they do need to be public. Great. We got to give a return type. Delete. Purge. And finalize. So you can see as soon as we've done that, all our errors here go away. I don't know why this is giving us an issue. Just rename this to path to shut up the editor. think it's just a keyword used by something else, I don't know. So up here at the top, once again, we're going to need to use the Unity editor. And we're going to add a flag to our script. This one's just going to be execute in edit mode, so we don't have to play our scene. So we can just use it in the editor and actually use it as a tool. We're going to need some variables. We're going to need a game object for our path prefab. So we'll just call this object to spawn. We want to be able to assign this in the editor. So we're going to add a tag at the end, right at the beginning, sorry, serialize field. What this does is it means we can keep this object private so other scripts can't interface with it, but we can see it in the inspector. We'll need a game object for our goal. We'll need a integer for our steps. Once again, we're going to serialize this. And we're also going to give it a range from 1 to 100. What this is going to do is if we save this and come back to the editor, if we create two empty objects, call one origin, call one goal. If we add the generator script to the origin, we're just going to give them a gizmo, just so we can differentiate between them. With the origin script, we add it here. We'll just give it a random cube. You can see here we now have a slider. It lets us go from 0 to 100, and we can't, no matter how hard we try, we can't say give it a negative number, we can't give it a number bigger than 100, it will be clamped in between these two. We'll need a list to store all our spawned objects in, so we create that by creating a list, give it a name, path list, is equal to new list. You can see this will give us errors because we haven't defined a type. So in here we're just going to type game object, which is just Unity's way of storing objects. Another serialized. This time it's going to be some booleans, which are a true or false value. Should live generate path, should face towards goal object. So what these are going to do is the live generate path variable is going to determine whether or not it will update as you're moving the objects around. It's just a good performance thing to have. And should face towards goal object, it's just going to make them all face and look at the goal object. Awesome. That is all our variables defined and all our functions defined. We just need to use a couple of generic Unity functions and we should be good to start coding. So first one is onValidate. So what this function does is every time a variable changes in the inspector, i.e. you're changing the step count, it will call this function. We're just going to simply check if we shouldn't live generate path, which is indicated by this not operator. So just call generate. That's the onValidate function done. Quite simple. We now need one for update. If we should live generate path, generate again. So basically what these two functions are doing is this is being called every time we update this or press one of these buttons, it will just regenerate the path, especially when we're moving the objects around. That's when updates are very useful. And the onValidate's when we move the slider, as update doesn't catch that. Just do a quick debug function and we're ready to start coding our actual logic. So for this, we're just going to call onDrawGizmos, and we're just going to draw using the Gizmos class. We're going to draw a line from the current position to the transformed position of the goal. So as you can see, it's not drawn anything yet. It's telling us, hey, the goal hasn't been updated. See, it's really shouting at us. So all we're going to do is we're also going to start working on our code. In our generate, we're just going to set goal is equal to gameObject.find goal. You can see now a line will get drawn between our goal and our origin. Again, this is only shown in the inspector, but it's still good to have just so we can keep track, because even if we get far away from the two icons we set in the inspector, the line will always be there. It'll draw above anything. It's drawn and it's rendered on the top, so no matter where we are in the scene, we can see it. So now we can move on to our logic. We're going to check if our pass list count is greater than 0, so basically how many items are in the list, and if it has some, we're just going to call the delete function, get rid of any old paths. We can then start afresh. To store our paths, we're going to need to create an empty game object, which we do by typing game object, giving it a name. So giving it a variable type, giving it a name. I'm going to set that equal to new game object, call this generated path. We're going to set the transform, set parent, sets equal to transform. What this is doing is it's getting our new empty object we've just created and parenting it to our origin just to make sure it all winds up, and then at the end we can separate it off when we need. We're also just going to add this empty object into the path list by calling the add function of the list, just so we've got it, and then it makes purging a lot easier. We can just search anywhere for the names, and we're going to set the position of the empty object to equal the position of the origin, because if you remember, this script is on the origin, so whenever we call transform.position, it's the position of our origin object. We're going to loop over each object in the list. We do this with a for each loop. What this does is it'll start on the first object, we can do something, move on to the next, do something, move on to the next, do something. Here, all we're going to do is set the parent of that object to the to our empty object. So it's just going to make sure it's under it, just to make sure it's aligned. Bit of a long line here. We're going to check if we should face towards the goal object. And what we're going to do is we're going to set the under the transform class of the object, we're going to call the look at function. We're going to set this to the position of the goal object. Take our path list dot count -1 transform dot rotation is equal to path list 1 dot transform dot position. Not position, sorry, rotation. There we go. And so what this second part is doing is it's looking at the last object. So it's going to loop over every object that we've spawned, make it look at the end goal, and then with this, what this part's doing here is it's just getting the last object in the list and just setting it to the rest of them, just so it's all in a straight line. Almost nearly done. We've just got to do our loop logic and our deleting, purging, and finalizing. So for our loop object, what we're going to do is, and this is the mathematical part, and this is the part that racked my brain for a while. We're going to create a for loop, set the original variable to 0, check if I is less than steps plus 1, because don't forget, not only do we have our empty object at the start of the list, the way lists are indexed, this just compensates for it. In this loop, we're going to get a new game object. Rather than calling new game object, which just creates a new empty object, we want to instantiate. What this does is if we pass in a variable, for example, object to spawn, it's essentially the same as just dragging the object into the window. It's going to take whatever prefab we give it as a variable, and it's just going to create it as it is, just in place. So here's where the math starts. We want to create a float, which is a decimal number. We're just going to call this percentage. I'm going to set that equal to I divided by steps. So what this is going to do is this is going to give us a fraction. So it's going to see how many objects we want to spawn and the current one we're on to give us an equal fraction. Now, if we were to run this as it is currently, it would error out because it's trying to do integer calculations on and cast it to a float type. So all we have to do is cast these two input variables to a float, and we do this in brackets before the variable name. This just is basically telling the compiler that, hey, this integer that we have right here, we actually want to just treat it as a floating point or a decimal number. For some reason it tells me cast is unnecessary, but in my testing it just hasn't worked. So we then want to take the object we've just spawned and we're going to get the position of it. We're going to set that equal to the lerp function of the vector3 class. What this does is it just gives us a value between the start and end point. You can see it gives us, it's essentially the function a plus b minus a times by t. It's very complicated maths, this is just the way I managed to figure it out. The starting position will be the position of our origin object, which we reference like so. The end position will be our goals position, and our time will be percentage. We're then going to add our object we've just spawned to our list, and that is the majority of the code done. We now just need to work on deleting, purging, and finalizing. But this part is the part that racked my brain for so long. I tried everything. I tried manually implementing the lerp function, I tried manually doing the vector math, and it just hurt my brain. I spent about 3 hours on it. Now we need to move on to deleting. We do this by using a for each loop. You can see here we're just saying we want to loop over every game object, give it a variable name to interact within the function. In our list, we're going to destroy it. Now Unity does have an inbuilt destroy function, but this only works in runtime. It doesn't work in the editor, so we have to use the destroy immediate function. Outside of this list, we're also going to wrap this for each loop in a for loop. But rather than checking if it's less than steps, we're going to check if it's less than the path list count, so the total amount of items in the list. The reason why we're wrapping it in a for loop is so we can path list.remove list I. So what this is doing is it's just removing a game object from the list, and we're giving it whatever our current index is. Path list.clear, just to remove all the entries after we've removed the objects. Now you can see with the destroy immediate, just delete these, generate path. You can see our generating works fine, but the deleting isn't working. And you can see it's saying destroying game objects immediately is not enabled in blah 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 blah. You must use destroy. Okay, well I'll change this to destroy. Yet when we click delete, it says you cannot call it in edit mode. Use destroy immediate. So we're in a bit of a rock and a hard place. So how do we fix this? Well, it's quite simple, except it hurt my brain to figure this out, and a lot of wiki searching. So what we're going to do to fix this issue, inside the Unity editor namespace, we're going to access the editor application class, and we're going to run the delay call function. We do that like so. And then inside here, we can destroy immediate the game object. It's very confusing. I don't know why Unity does this. This took me a long time to figure out. A lot of forum searching. Stack Overflow was my best friend. But that is the delete function done. Onto the purge. We're just going to, in a while loop, we're going to check whilst we can find a game object called generated path. We're just going to game object.destroy immediate game object.find generated path. So what that's going to do is it's whilst there's an object in the scene called generated path, it's going to remove it, and then that's just going to keep running till there is none. For the finalizing of the path, what we're going to do is we are going to game object.find generated path. We want a reference to the game object, so we're going to get the game object that's named generated path. We're going to set the parent, set that to null, destroy immediate game object Find origin. Destroy immediate game object. Find. Go. So that should be our entire script done. You can see our two lines are being, our line is being generated between the two objects. We can give it an amount of steps we want. Face towards works, especially with higher values, but that's just inefficient, just scale a cube. But you can see we move around the goal, it updates. It is a bit laggy purely because you can see quite a bit of ghosting. I just think the update function doesn't run that fast. So you can see I can do little circles. But it updates, add as many objects as we want. So we can stretch them out as long as we want, and it will always do them at equal intervals. Turn off live generation, and we finalize. Cleans everything up, and we have this empty object containing all of our instantiated ones. Thank you guys for watching this tutorial. If it helped you understand a bit of vector math, or if it helped solve the problem you were looking for, a like, comment, and or subscribe would be very much appreciated. I want to thank all of you guys for taking the time out of your day to watch this video. If you have any ideas for anything I can work on, please leave it in the comments. I'll be sure to check it out and make it as soon as I can. Thank you guys for watching, and I'll see you all next time. Peace.